Hello everyone, I am Sivasubramanian, LHG assignee for Comcast. My parent company is L&T Technology Services India, and this session we are going to talk about OpenCDM or CDMi work with WPE and multi-DRM support. This session will provide an overview of Linaro CDM, CDMi work with WPE and Chromium browser and multi-DRM solution using OPTEE decryption on HiKey platform. So the main focus will be how we added WPE browser support to existing Linaro CDM and its validation with different DRM systems on a RDK media client based image. Okay, so before moving into OpenCDM, let's have a quick recap of what is RDK, Westeros and WPE. We have already ported RDK media client that is Morty based image onto HiKey, and we already given a talk on the previous connect on how that is. So let's have a quick recap of what is RDK and the WPE. So RDK is a complete set of software stack components, tools and documentation that help faster development of set-top boxes into market. It's pre-integrated, modular and open source bundle that provides a common framework for powering on set-top boxes, CPE, other CPE devices. Okay, so RDK uses RMF, that is RDK Media Framework, which is based on GStreamer for media functionalities, and WebKit Wayland for web and graphics rendering functionalities. And there is a link for the code repo. So some of the RDK components are being open sourced and some are in the process of being open sourced. So that's available in the GitHub /RDKCMF link. And so as I said, RDK uses Wayland, it requires a compositor. So Westeros is RDK's inbuilt compositor. It's a simple and lightweight to be suitable for the embedded system. It supports most of the compositing, normal, nested and embedded compositing like Western, and the source code is completely open source and it can be found in GitHub RMF Westeros. So coming to the browser side, RDK uses metrological WPE, that is web platform for embedded browser. It's a standard port of WebKit with Wayland support, Wayland display protocol support. Okay. So it supports video playback, graphics and web rendering using GStreamer media framework and WebKit web framework. So the code repo can be found under media organization metrological, which has that WebKit for video, WebKit for Wayland, and the recipes also, the meta WP layer also available for compiling this WebKit for Wayland browser on the same location. Okay, so let's talk about OpenCDM now. So what is OpenCDM? OpenCDM is a content decryption module developed according to W3 standard to be used with different HTML browser and different DRM ecosystem. It's built with modular concept in mind to be extensible with different browser. we'll see how it is extensible in the next coming slides. So it provides common CDM and media engine APIs to be invoked by browsers using browser glue layer. And yeah, so the Fraunhofer focus first developed open content decryption, that is CDM and CDMi, that is being used as a common reference across different folks. This is how it is layered. So we have a browser glue layer where support for different browsers will be there, means Chromium or WPE, that will be there. So the calls from EME is routed to corresponding CDM or media engine APIs using this browser glue layer. And next we have a core layer where you have a CDM and media engine components. So CDM will have the core implementation of CDM session, and media engine will have the media data related implementation. And next is the communication. So the EME calls from CDM is routed to CDMi using this communication layer, and this is done using RPC interfaces of the native OS. Yeah, so CDMi is a content decryption module interface. It's again developed according to that W3 EME standard. It contains the most of the CDM logic, and it's a wrapper over a different DRM system. This encapsulates the DRM dependency and provides a common RPC interfaces to OpenCDM. So as I said, OpenCDM uses OS native RPC mechanisms to route the calls to CDMi, and CDMi will in turn route to a particular DRM. So that we'll see in next slide. And yeah, so the media content also, as I said, media engine will route the media data using RPC to CDM, and CDM will route it to DRM or OPTEE for secure encryption and playback. Yeah. So OpenCDMi runs as a service which provides common RPC interfaces for OpenCDM to invoke, and it's kind of a 3-layer. So the first layer is that RPC to CDMI service mapping, and we have a core CDMI implementation, that is service implementation, that will decide which DRM to be invoked, and that is compile time configurable. So either we can compile CDMI as a ClearKey CDMI or PlayReady, so that's compile time configurable. So that core CDMI service will route the call to corresponding DRM, and DRM where the actual decryption, all the license management, all those things will happen. Yeah, this is the overall flow of encrypted content playback on a browser. So EME application running on a browser will talk to OpenCDM using the browser glue layer. Let's say create session call. So create session call will invoke the browser glue layer of the corresponding browser, say WPE or Chromium, and that will in turn translate into CDM where the session metadata, all those things will be handled, and that will be routed as a RPC call to CDMs that I want to create a session for ClearKey with this data and any data, and then CDMi service will route it to the corresponding DRM, and based on the DRM support available on the hardware, that session will be created. So as I said, this OpenCDM has two components. That CDM part will handle the session metadata, key exchange, all those things, and media engine will come into picture once the license management has been happened. Means once the session is created and the license URL that license URL is received from CDM, and that license has been validated with DRM. So after that only we'll have the data path, and so once that session is created and license is validated, browser will start sending data, and media engine will create a media engine session, and that will use RPC to transfer the data between CDM and back here. Means so media engine will send the encrypted data to CDM, and that is decrypted with respective, means corresponding DRM, and the decrypted data is transferred back in place to media engine, that is being given to browser. So one thing to note here is we don't have a fully secure data path on the platform HiKey we have. So currently only the decryption is happening in the secure val, and the rest of the playback, decoding and playback is happening in the normal world. So this is some overview of what is DRM, types of DRM, and what is OPTEE. So DRM is a system to protect your content according to the constraints associated with the content. It varies from a basic protection to a sophisticated content protection using license key management and other things. And we have different types of DRM. So ClearKey, which is open, and Microsoft PlayReady, which is licensed, and we have a Widevine. So that that's all the DRM we are considering, and we have other DRMs also in the ecosystem, but we don't means currently have that support. Okay, so OPTEE is so what is OPTEE? Open Portable Trusted Execution Environment. So it's designed to be rely on ARM trust zone technology to protect the content from the normal world. So as I said here, decryption only happens in the secure world, but in fully secure data path, even the decryption key, everything will be in the secure world, and so decryption happens in the secure world, and the data playback, everything will happen in the secure world. So the data is completely protected from the normal world. Okay, this is about the ecosystem. So we have multiple forks of OpenCDM with different browser supports and different DRM supports, and it's being implemented with different EME versions. We have like EME 0.1, V1, and different versions are there. So it's like different folks have means going in a different direction. So let's take the Linaro CDM and WPE CDM, and we have listed some of the difference in the table. So browser support wise, Linaro had only Chromium. We added WPE, and the WPE RDK has its fork of CDM, CDMi, and there it has only WPE support, and the CDM part of RDK WPE is restricted, so I'm not enclosing that. So coming to the Linaro CDM, CDMi, it's open one. So currently we have ClearKey and PlayReady support. So Widevine support is in progress, so that we'll see. Okay, so since we have multiple forks of CDM, CDMi with different functionalities, so Comcast or RDK want to unify this effort into a single upstream CDM, CDMi. So we took Linaro CDM, CDMi and added WP support, and so thereby we want to make Linaro CDM and CDMi as a single upstream going forward with different browser functionalities and different DRM functionalities. Currently that Widevine functionality is not there, so that's a work, there is a work in pipeline. So yeah, so we added WP browser support in addition to the existing Chromium support, and it's being validated with ClearKey content playback, both with SSL and secure OPTEE decryption, and we have PlayReady, and validation with PlayReady and Widevine is in progress. Okay, WP support on Linaro CDM and CDMi. So we took WP fork of OpenCDM as a reference, and we added the support to Linaro CDM and CDMi. So we added browser glue layer under source browser where the support for different browser exists, and we reused some of the EME implementation which is already available with Linaro CDM, and we added some of new EME APIs, as Linaro CDM is pointing to an older version of EME, but the WP fork is pointing little latest one. So we had to add some of those EME implementation to Linaro CDM, and we did a RPC unification between CDM, CDMi. Since Linaro CDM, CDMi already had a RPC communication mechanism, but WP has a higher version of EME, so we need to add some more APIs, so that was conflicting with the existing RPC implementation with Linaro CDM, so we had to unify that communication interfaces between Linaro CDM and CDMi so that it works for both Chromium and the WP browser together. Yeah, this all the contributions we did. So the WP support we added, it's sent as a to pull request, which it's being reviewed by the Linaro team. I mean, it went few review cycles and it's about to be merged, and we upstream the changes we made to validate the ClearKey playback on WP. That's on that we upstream to the WP stable branch. and we did some changes to make 32-bit of OPTEE work on our system. Since RDK is 32-bit, we need a means 32-bit of OPTEE, so that changes also be upstream to OpenEmbedded Meta Linaro layer. Okay. These are the current and the future activities that are ongoing. So currently we added WPE support to the Linaro CDM CDMi, and it's being validated with ClearKey playback, as I said, and the validation of WPE with PlayReady 3.3 and Widevine is a work in progress, so that's in pipeline. And we also regression tested with existing Chromium support, so that we don't break any of the existing Linaro CDM functionalities. Okay, so there are some of the future work, like adding Widevine support to Linaro CDMi and updating it to the latest EME standard. So thereby making it a single upstream CDM, CDMi across the ecosystem. So there are coming to the reference board platforms. Currently we use HiKey. As I said, it doesn't have a full STP. So only the decryption happens in the secure world. So we are looking for a board with fully secure media path. So we are considering Poplar or IMX in the future. So the next will be once we validate the board, we will be doing this work with a fully secure data path on one of these platforms. So that's a future plan. Okay. Any questions before we break? Okay. Thank you.